Hey, if you could open your notebooks to this page on contingency tables. Now, contingency tables are, to me, one of the best ways to look at probabilities. They're easy to set up most of the time. Set up for you. So right here is we have what is an example of a contingency table. Now you're going to notice in this case the table has been totaled up for you. This way, this is a row total like 117 plus 50 plus 60 equals 227. And then this way, you have your column totals. Now this number is either these two numbers added up or these three. The grand total of what these two row totals should equal and what these three column totals should equal should be the same thing. Okay, so now when you're dealing with the contingency table, in most cases, you're going to go at the grand total. That is unless you're given some kind of conditional probability where you're given, or that A slash B. So for instance, right here, we're going to start by giving the probability of girl. Well, it's going to be given by grand total, and there's 478 total people. Of them, 251 are girls. Okay, so girls, and then your grand total. Okay, sometimes you can change this to a decimal, sometimes you leave it as a fraction, sometimes you give it as a percent. So that's going to be a 0.525. Okay. Now, for this group right here, the probability of a girl and popular, I'm going to look for the intersection. Still, this is an and, so it's still going to be out of the grand total, which is 478. Okay, so I'm looking for girl and popularity. There's girl, there's popularity. So girl and popularity would be 91. Okay, so the probability of someone being a girl and popular is 91. Now back to sports. Okay, again, it's just sports, so that's going to be out of my 478. That's still going to be my total. Then I need to look how many people play sports total. Okay, that's a different number. I'm going to go right down here. My total number for sports is 90. So that's going to be 90 out of 478. And again, sometimes you change these to decimals, sometimes you don't. You just need to follow the directions and know they can be in multiple forms. Okay. Now the last one, it says the probability someone plays sports given they're a girl. So you see this given part right here? This means my bottom number is going to change. So now what I'm looking at is only the girls. So my bottom number is going to become 251 because now I'm only interested in that row. Now if I'm looking at that row, I need to see how many play sports. So of the girls, 30 play sports. So assuming that it's a girl, that's where we got the 251. 30 of them play sports. Okay. We are now going to flip your page. The last, just checking, this is at the bottom of the independence page. Okay, so this is a similar kind of problem. And it says, let me move that up, and I'm going to zoom in just a little bit. It says, remember one of our sample pages in this book from earlier. Okay, they said 48% of the pages had a data display, 27% of the pages had an equation, and 7% of the pages had both data display and an equation. They want us to make a contingency table for display and equations. So when you do that, pretty much you're going to have display, no display, and then over here I'm going to have equation, no equation. Now, what I need to keep in mind, if they give me percents, I want my grand total to be 100. So now I need to put what happens in here. So right here, 27% had an equation, 48% had a data display. So at the end here, for had an equation, I'm sorry, let's start with data display. 48% had a data display. So that's going to go right here. So if 48% had a data display, 52 didn't. Then it says 27% had an equation. So 27% had an equation, which means 73% did not. Now, the trick is trying to get in the rest of it. It says 7% had both data and equation. So data and equations, that's going to be 7%. So if this is 7, 27 minus 7 makes this 20. If this is 7 here, 48 minus 7 makes this 41. And then right here, I can finish this math one of two ways. Either way, it's going to be 32. But all my numbers now add up. So now that my table's complete, I can go ahead and answer these probabilities. So what is the probability that a randomly selected sample page with an equation also has a data display? So it says with an equation. So just like before, I'm going to my subgroup. So for A, or actually B, my bottom number is going to be 27. So of those with an equation, does it have a data display? Well, 7 out of 27 makes that the case. Now, for C, it asks, are having an equation and having a data display disjoint events? Meaning, can a page have an equation and have a data display? Well, equation and data display, I'm looking at the number there. It's not 0, so it's not disjoint. So no, it's not disjoint. So not disjoint, you can have both. A page can have both. Okay. Now, what we're going to do is we're going to do D tomorrow in class. Actually, today, Monday in class, when you have that, we'll talk about the independence definition.